Welcome everyone to another version of our Tech 90s. Today I got myself and Daniel Hamrick with me.
Good morning, everyone.
Today we're going to be covering outdoor unit board replacement on single and multi-zone. Rundown of what we're going to be covering is first we'll cover why knowing and following the proper steps to replacing the board is worth repeating, which I firmly believe we need. There's a lot of guys that really don't understand the importance of the step-by-step process to make sure this gets done right. There's a lot of YouTube videos I see where guys are changing boards and oh boy, they're not following proper procedure, and I have a feeling that they are actually replacing that board more than once before they get the job done correctly. So I think it's very important that we cover this. Then we'll run a piece from the recent training that introduces some of these concepts. Then we'll come back and chat with you live and answer questions up to that point. After that, we will run the remainder of the training as we finish up our board replacement process. Then we'll finish up with another live Q&A session afterwards. So we're going to play a segment, break, Q&A, play a segment, and at the end we'll do it all over again with live Q&A. So we encourage you guys to get into the conversation. As a reminder, if you have any questions or comments at any time during this broadcast, use the question mark icon to the right of the screen and send them our way. We'll answer any relevant questions until we run out of time. I can't reiterate that enough, guys. This is for you guys, not for us. So please, get involved, ask questions. Some of that stirs other thought processes that Daniel and I might have that kind of leads us into something else that may be important for you guys to know when it comes to board replacement or board diagnostics and stuff like that. So again, this is the opportunity to connect with us and become more comfortable with the latest GREE comfort. Tech 90s. That's why we do what we do, right, Daniel?
That's right. So yeah, we love the involvement. We had a lot of fun with this. I remember doing this, down in Atlanta, and it was a really just kind of one of those first for us, and seeing how it worked, and we were able to zoom in and get really good shots of what we're actually doing during the board replacement, and talk about the wiring and things to check and things to look for. So hopefully you'll get a lot out of this, and I look forward to any questions that anybody has. Love to answer the questions.
Yeah, and I want everybody to be a little patient with it too, because we could have sped up some of the video because we had time that we could edit it. We're not doing the live broadcast anymore. I reviewed the video. I chose not to edit any of it and then speed up any of it, because if you look, as you're watching it, you'll see there's things that Daniel and I, as we're doing it, we're like, oh, let's talk about this. Let's talk about that. So I just felt like if we cut it up, we could have actually made this shorter, but I think it would have actually not give you as good information. That's why I chose to just leave it alone. So this is exactly how it aired when we originally live broadcast. So anything else to add, Daniel, before we get right into?
Let's get started.
Throwing up some video. All right, sounds good.
All right, here we are back again. All right, so what we're going to do now is we're going to start with taking this board, the whole electric box assembly, out of here. So part of the reason why I wanted to show this is because, and not necessarily on this machine, but in quite a few of the GREE mini splits, and I've taken the calls myself, where technicians have tried to replace this board, and they're doing it without removing the electric box assembly when the board is installed vertically, just like in this unit right here.
Yeah.
And that's where we want to show you that in order to do a board replacement in here, they need to pull the whole electric box assembly, because they're not going to be able to facilitate getting the board changed properly with the electric box assembly in here. They don't have enough clearance here, and you will also see that on this other unit too, that they're kidding themselves trying to do it. when it's vertical like this.
And it takes
So-
less time to take the electric box assembly out and put it on a bench, just like we were talking about earlier, to sit it out and do what we need to do, and we'll demonstrate that, which shouldn't take us too long, actually.
Yep. So we'll go ahead and get this popped out of here, and
So as you can see, it's loose. We just need to get the wires
we're
loose.
gonna get these wires off. And again, best thing to do, the wiring diagram shows it, but just take a quick picture, then verify your picture. Make sure you're going to be able to read it when you need it, which I can.
Notice on these,
But I also
Stay-cons.
realized with this one here, you could just take these two screws out right here and leave the
Yeah,
wires
you could,
connected.
couldn't you? Let's do that this time, since we didn't do that last time.
And then your ground and your wires all stay connected, because we don't really need to unhook it there.
But if your electrical was connected to this unit as it were
You
installed,
got to take that one too.
then you would
You got to take that.
find it a lot easier just to take the stay-con off of there compared to what we're doing. So technically, it's just one screw here taking the entire block
Oh yeah, so we didn't even
off
need
of
to
there.
take them.
We didn't need to take those other two out.
See,
So
we're
I'm
like
gonna set this
we're
right
like
here.
auto mechanics. Take more apart than we need to.
Yeah. And
That's
then
great.
when you're done, if you don't have 3 screws left, then you haven't done the job right.
Pop this out. I believe we got 2 wiring harnesses here we're going to unplug. Yep. All right, so we got a couple
lose
plugs
it,
on this other
you
side.
replace
I'll
it.
let you get those.
So these 2 cables here come out from there. This assembly has a nice cover on the front of it to route the wires through. Keeps everything nice and clean. And also keeps your wires from rubbing on things that it shouldn't and shorting out.
Now the keepers on this we didn't have to remove because we've already done this once on this. We've already removed the keepers. So
Hence why we say no need to put them back.
all right, we
Because
got
if
the
anybody
compressor
ever has to do it again,
plug.
makes it a lot easier. That one is, there we go.
All right, so that board's out. Okay. Now we'll go to this other machine here in the corner to where we had the vacuum and everything showing there, and we'll pull this board out as well. Now I believe this one is actually inverted,
It is.
so you
So
wouldn't
this one
necessarily
you could
have
replace
to.
without
you could do
removing
it, yeah. But this is the one that we have the replacement board for, so that's why we're going to show it to you on the bench. All we're doing is undoing cables, getting them off the top of the box, getting them off the side of the box.
All right, so I want to take a moment and talk about this compressor plug.
Okay?
So the compressor plug on this particular one, it has a plug in between the compressor and the board. So the wires are made into the control board. So there's no worry about getting the phase reversed when you're unplugging and plugging the compressor back up. But we have seen, and I've seen it, you've seen it, several instances where all it was, it had an H5 code, and the problem was that this plug was not seated properly. Now the one that you had, the wire or the terminal was
Something
not
was
pushed
wrong
all the way
with
up
the
into
wire into the Mullex
the plug
plug.
was damaged
Yep.
in some way.
So the technician on the job, what he ended up doing was just cut them off, cut the Mullex plug out, butt spliced all together, and we had the unit up and running. It's convenient. It's convenient to have the plug to be able to just unplug it, but when you're in a pinch, you do what you got to do, right? So that's what he did.
All right, so in here
We've got our EEV plugs. They're color coded, so pretty easy to put them back where they go. Most of the Molex plugs that you'll see on here are going to be color coded or different sizes or different types.
Right.
So I haven't had one where I've gotten anything mixed up before, but I will say if you have a Stacon, like your incoming power, so your blue wire right here goes to a Stacon, your brown wire and your black wire goes to a Stacon. Blue is ACL, I believe. The brown ACL2, one's ACL1, one's ACL2, and then the other one's COM coming from over here on your terminal block. And those hook into the control board. If you unplug them, you want to make sure you take a picture of those, make sure you know where they go. It's pretty easy to see on the schematic where they go, which is I had one recently that and this was, we were talking earlier about the Flex where the H6 code is outdoor fan motor, and then on the mini split, the H6 is indoor fan motor. Well, this technician got confused and replaced the outdoor control board for an H6. Didn't do him any good, but he did create himself a problem in that he reversed the ground in one of the power wires. Fortunately, it didn't mess anything up, but it wasn't working. Once we reversed those two wires, then it started working. He did end up with an H5 after
Which, and it does make sense, because if you remember your 14.4 wire going to your indoor unit, you have 1, 2, and 3, 2 being your communication, 1 being part of that communication, 3 being power, 1's also power. So that communication circuit coming from that board to the 1 and 3 is actually critical so that it communicates properly. So reversing those 2 wires on the board is what ruins your communication.
Correct. And most of the time, you're not going to damage anything. But sometimes you could blow a fuse or damage the board itself. So, all right, there's those out of the way there. And then
I think we got to pop this. Did you get these wires off yet?
No.
Okay.
You want
Once you get them, no. Oh, you want to take them off here, or you're going to take them off over there?
Take them off there.
Okay.
You just need to remove. Well, no, we don't have to remove those.
That's what I was going to say.
This is loose.
But they're caught on the box or something is what I'm getting at. I didn't get that screw out, so it's going to pop
That's okay.
out. Just so you know. All right, cool.
And there it is.
Give me that screw.
The heat sink's kind of sharp, so you got to watch the edges.
Yep.
All right, now we're going to move over to our board replacement station we have set up.
Yep. All right. As I talked about in the inverter design and operation, I also talked about the P and N terminals. I talked about the DC plus and the DC minus. I use this in troubleshooting. I will have a guy on the phone, and I'm like, hey, let's check the DC bus. On the ones that the board is face down like this one is, we can pull that cover off, and I can have him take his meter leads right onto those 2 solder pots, right there where it says DC plus and DC minus. He's got to dig in just a little because there's silica on top of the board, but it gets
That's where the needle point connectors come in handy.
Yeah, because they're sharp.
They're sharp, and all you have to do is just touch them. It'll
But
go
anyway,
right through that silicone.
I can have him check that DC bus, and right away that tells me whether or not that board was powered.
Yeah.
I mean, I may have a blown fuse on a filter board, and I have no DC bus, and just by quickly checking that also eliminated that fuse. Okay, so when I'm talking about that fuse, if we look at this filter board I have sitting here, so because on some of the older multi-18s and the multi-24, they have a separate filter board. And that fuse, if that fuse is blown, then you lose power to the main board, so you won't have any DC bus at all. If you look at that, the multi, like a multi-18, again, it'll be the CO, not the EO.
The CO. This is the main board here and the filter board for a multi-CO. And I'll move this out of the way a little bit so you can see both of these. you'll notice that the current Gen 2 Multi-18 that we just removed, there was no filter board in there. There's no separate filter board. It's built into the board. The C revision had a main board and a filter board.
But what I've actually had guys do on the phone then is if you look over, like if you're standing on the end of that unit where your 14-4 wires go into it, and they look at over the edge of the top of the painted panel, with that board, the main board's upside down in that unit. So if you kind of picture this is upside down in the unit. This filter board is mounted underneath of it somehow. And if you're looking over the painted edge of that panel and underneath this board, you'll see that fuse. And there's enough room in there, and I'm going to pull this back a little bit, that they can actually take their meter leads and go in there and take a voltage reading across that fuse. And if they're reading voltage, then that fuse is blown. So we know right then and there, that filter board is bad. So then the next thing that we will have them do, instead of just saying, all right, you got to get a filter board, what we will have them do is take alligator clips and a 5-amp fuse and just alligator clip across that fuse so we can get this board powered back up. So we can actually troubleshoot this board too to see if we actually have a main board failure
Or just a filter
or
board.
just a filter board failure. If I jump around this and that thing already clicks forward and the condenser fan motor comes on, the compressor's getting ready to start, then I know all they need to do is order a filter board. And then we've also had many calls, and I'm sure you've taken them as too, Daniel. They've replaced this board.
But forgot about that board.
They replaced this board, and this board's got a blown fuse.
Yep.
So, and then this one is the same as what he was just talking about with those blue and brown wires going to your N1, N2, and 3. The same thing happens here. If they cross those wires up, you're not going to get proper communication either. So It's very important that they're following the wiring diagram and the blue wires landing where it's supposed to and the black wire and brown wire land where they're supposed to do, because again, you're coming back to 1, 2, and 3 on that terminals, and it's very critical as far as the way the board powers up the communication circuit. So if we cross those wires up, chances are it won't hurt anything, and it's just a matter of reversing the wires afterwards, but it's hugely important that they get them in the right place for it to function.
The other thing that I'd like to mention is that, you know, if you see that the model has a main board and a filter board, it doesn't mean get both and throw it at it. It means we need the technician on the job to actually see which one they need.
They may need both, but many times they don't need both.
A few years ago, we ran out of these over the summer because everybody was just replacing them. If it's failed, yeah, great, order it. But if it's not failed, then, you know, let's save it for the guy that actually needs it.
So we just got done doing EEV testing and opening out the EEVs. So let's use this board here to kind of point out that EEV circuit and what we can look for as far as burn spots on the board.
So on the control board, you'll see FB and FA. Right next to where those connect on the other side of the board, they connect there. Those are the Molex connectors. Here is these little chips. And what will happen if you have a grounded EEV, you're going to have a burnt spot in one of these little chips. And so there was one particular model that we had, this happened more so than any one I've ever seen. And it was a multi-24CO. And for whatever reason, some of those EEVs would ground and you'd get a burnt chip. So what I started doing was just asking for a picture of the board, of the back of the board. I would zoom in on it when we're troubleshooting E6, and you know, if I saw that burn mark, then I knew before I mentioned getting a board, I knew to tell him, check your EVs, see if one's grounded. You're going to have to replace that as well.
Because if they don't, they're going to just smoke the new board.
And now you've got to get a board and EV. So third job site visit.
That's one advantage that we do with our phone system that we have. We will do text messaging with the guys. We can also do email with them, and we will have them send us pictures. And I tell them, hey, don't get right on top of that board. Stand back and take that picture, because then once I get it on my computer and download
zoom in.
I can zoom
Blow it
into
up.
it and see where I'm at. And that's what I'm looking for, is any burnt spots on the board, like around the EED or
exactly.
something like that. And then back to the discharge points that we were talking about a minute ago, I will use this rather than dive right into, you know, seeing if I got a grounded compressor or shorted windings or something. If this DC bus is real low in voltage, then I can have them unhook loads. So I can have them unplug the compressor. I can have them unplug the condenser fan motor and then power the machine back up. And if this DC bus all of a sudden comes back up, and let's say I just unplugged the fan motor, now I know the condenser fan motor is what's dragging my DC bus down. Now the mini split service tools that we're going to demonstrate to you out in our warehouse lab, those actually will give you the DC bus as well. And I've actually taken calls where the guy has had that service tool and his DC bus is low. He didn't have to get a meter on the board, but the DC bus was low. Unhook the condenser fan motor, DC bus come back up, and I'm like, well, there's your problem.
There, you know what it is.
So, and if you, even if you know, you can take it one step further and ohm out that motor as well, and you're probably going to find you got a shorted winding, but that's what's causing it. And it could actually be the compressor circuit as well. But keep in mind, that's only going to happen with DC loads. So if you have like your crankcase heater, your reversing valve, your base pan heater, those, don't even worry about unplugging those, because those are all AC loads. They're not going to drag down that DC bus.
DC bus.
EVs though could.
Yeah.
So, you know, if you've got a problem with the
12-volt
EV,
DC.
that could be dragging down your DC bus as well.
Yeah.
So, just kind of, and then that's the older board. This is the newer board. This board also has those DC discharge points where you can use them for facilitating troubleshooting as well. So, now not all the boards can you get to that, unfortunately. But when you can, let's use that to our advantage. We would demonstrate replacing this board, but when we checked the inventory, we didn't have very many.
We
of them
had
in
a
stock.
low amount,
So we didn't
wanna
get this
order
board. So we ended up
any.
ordering this board because we had plenty of those in stock, and that's what we brought down here for demonstration purposes. But the procedure doesn't change. But what I was mentioning in there on that single zone, if I can get this outer cover to pop off, they're not going to get in there and get to these screws without one, dropping them and losing them, which we can't have, and we'll explain why. And then they're going to have a lot harder time getting all the screws back in and get them in properly. So what I'm saying is the chance of them getting that board changed and that unit functionable without pulling the whole electric box assembly and changing the board, their odds are really low, really low. But once we pull this board out,
there are no lost screws.
now I've got full access to do what I need to do to change that board.
Right.
So, but again, we're going to demonstrate it on that board.
All right. Welcome back, everyone. Now we'll do some of your questions here. We're not getting a lot of questions, so don't forget to hit that ask a question button and throw them at us. We do have some things that we do want to discuss, right, Daniel? That I thought was covered in the video, but I think we can cover it a little bit better. But before we jump into all that, there is one question that came in from Terry Grant, and we kind of wanted a little more information. So the question is, or not really a question, it's more of a statement. Hello, friends. I replaced a multi-board yesterday due to the entire unit pumping down during startup procedure. So the question that I have back to Terry is, did it correct it? So, Terry, if you would, just use the ask a question button again and give us a little bit more information on what actually happened there. So, because it's a great conversation piece, something to talk about, right? With that, Daniel, something I noticed in the video, we talked about the Molex plug in between the compressor and the board.
Right.
We talked about it at times, like any other Molex plug, you can have a connection problem right there. What we didn't talk about that I think is important to talk about is the fact that, before you condemn a compressor, when you're testing a compressor, and this is the way I do it with guys on the phone, I will have them unplug that Molex plug and ohm out the compressor from the Molex plug, between the Molex plug and the compressor, not the Molex plug in the board. Important to which end we're talking about. But let's say we ohm out the compressor. Now, these are three-phase compressors, so we should have equal resistance across the windings, no matter which wires we go to. We should have no resistance to ground from each wire. And I say that no resistance, I also want to make sure that everybody understands that if you read it in mega ohms, that's a normal reading. What we're looking for is like 0 ohms to ground, 100 ohms to ground, 1,000 ohms to ground. That would indicate that I have a grounded compressor. But if I read like mega ohms, because of the oil in the compressor and the compressor's design, you could actually get a resistance reading from the internal winding to ground through the oil and refrigerant in that compressor, and it read up in mega ohms, and that's normal. Now, we don't want you using a mega tester on it, but most of your ohm meters can also read in mega ohms, and guys think that might be a grounded compressor, and it's not. That's a normal reading. So, but let's say we ohm out that compressor from that Molex plug and we get an improper reading. In other words, we get open winding. Before you condemn that compressor, you need to go to the compressor.
The compressor.
Take the cover off, ohm out the terminals right there. Because if you get a proper reading there, then you obviously know you got a break in that wire between the compressor and that Molex plug.
And something that I have actually seen before when we're working through a call and we're testing the compressor, the compressor tests out fine. There is, if you saw in the video, there's a little magnet, a little donut in that wire harness that it goes through and it wraps around. So I've actually seen where one of the wires go into the compressor was rubbed on that donut, and it was shorting out to where, if you were testing a compressor, it's fine. But if you test the wire harness itself, you have an issue there.
So I just want to make sure we cover that. And then I've never seen it, but another simple test to do is from, like you said, on a lot of the boards, from the Molex plug to the board, they're soldered in on the board. Not all, some of them have spade connections. But it's important to do an ohm reading from the Molex plug to the board to make sure you don't have a problem with the wiring harness between the board and the compressor. Now, if it's soldered to the board, when you get a replacement board, you're going to get that Molex plug with it because it's soldered to the board. So,
but if it's not soldered to the board and you're unplugging it from the control board, when you go to put it back, just look at your wiring schematic to make sure your U, V, and W are placed in the proper place, because you could be running that three-phase motor backwards.
If you do that, you're going to get a rotation error.
Right. So we do have several questions coming in, Greg. Thank you, everyone, for submitting some questions. Terry answered. He said it didn't fix it. He got an H3 error code. What do you think about that, Greg?
Well, that's why I asked the question, because I had a good suspicion that replacing the board was not going to solve a flow problem on a multi-zone unit.
Right.
Because the chances of the board being an issue, and whether you've got 2 zones, 3 zones, 4-zone unit, effectively what would have to happen there is we're not able to drive the EVs on each circuit. And I don't see a board failing to do that on all circuits and it be the board's fault.
So we just had a really interesting call that both myself, you, Greg, were trying to help one of the guys and one of the tech guys solve. And what it was, the symptoms were, is that the system would, it would come on, the outdoor unit would start up and then shut down. And then it would go through the cycle over and over. but we weren't actually getting an error code, which is kind of surprising. But what they found out, and it was actually one of our guys, JD, he discovered what the problem was. And so it was, I believe it was a 2-zone or 3-zone, Greg? Yeah, 2-zone.
I don't remember off the
And
top of my head.
he had opened 2 valves for that 2-zone, but if you've got 2 line sets, keyword sets, right?
Yep.
You need to open 4 valves, not just 2 valves. So that may be something that that Terry might want to double check. You know, if he's got a 5-zone system, just go ahead and take the caps off of each and every one of them and make sure they're all open. Another thing that is common with a multi-zone is accidentally swapping the pipes where they go into each indoor. And then the other thing is accidentally swapping the wires where they're connected to A, B, C, D. Maybe you've got A connected to B, and so you're sending refrigerant to the wrong indoor, which if that's the case, then you could end up with a pump down type situation there.
But and that's the one that we seem to get the most of.
That
is
is a common
easy to do, and I'm not trying to beat anybody up out here, but when you're bringing them cables up in there, it's so easy to crisscross them once you get into the electric panel and not realizing you just hooked B to A or B to C or whatever else. So
right.
It's extremely important that we, you're diligent in making sure each head, your piping, if piping is connected to the A circuit, we know that unit's the A circuit. We got to make sure that wire is also going to the A terminal strip in that multi-zone unit. And then you do the next thing, the B, C, and so on. Because if you cross them up, as long as they're all calling, you probably wouldn't know a difference. But if you only have one calling, then you're going to get freeze-ups. You're not going to get refrigerant flow. So then if you take it one step further, like you said, and you actually cross the pipes, yes, you can absolutely get pump down because of that.
Yep.
So
100%. So Terry did say we did all that twice. So I would recommend giving our tech support team a shout. You can call us 888-850-7928. Be happy to walk through the job with you and help determine what is actually going on. But to just to kind of touch on this, you got a new install. I have never seen a failed board on a new install unless something catastrophic happened, like the improper power was hooked up or something like that. So
now we have had a couple cases, and because manufacturing's manufacturing, right? It's very rare, but it wasn't that long ago that we did have a multi-zone where the EEV plugs were crossed up inside the machine.
Yeah, you're right. We did have that.
And those are color-coded plugs, and also the wiring diagram shows you. That's another simple check to do, is make sure that our EEVs, are hooked up to A, B, C, D. Because if that's not right, then it's also going to cause you flow issues. So, and then if you replace the board, we need to make sure that each one of those were plugged back up in the proper and appropriate places as well.
And the times that all of the units that I've looked at, the EV plugs, they're color coded, so
right.
Pretty easy to see, visually. But if you don't see it as color coded, you can look on the board. It will say FA, FB, FC, FD. So make sure that those are matching up to the A EV solenoid, B EV solenoid, and so on. So we have another question from Joseph. It says, do you have more board failures on single zones or multi? What do you think, Greg?
I don't know that I've really quantified the numbers
haven't either.
But I can tell you this, it's a good time to talk about it, especially with board failures, that it's, when you're talking inverter boards, whether it's one, an inverter board and a filter board, or it's all one unit, it's it's in the consumer's best interest to have surge protection / voltage monitoring for that board, because I believe that is the majority of the board failures we see is not because of the fault of the unit. It's because of high voltage or power surges, because they just don't tolerate it. And that's not just GREE, that's any mini split manufacturer out there. These, electronic boards don't tolerate, high voltage surges. So if you see a board failure, if you have a board failure, something's burnt on that board. Sometimes, before you change the board, be conscious of what you're doing. And I think we talk about this a little further in the video, but where is it burnt on the board? Is it possible it's close to an EEV? Do we need to ohm out the EEVs and make sure they're okay? Is it burnt right by the IGBTs and the high DC bus? If you already replaced the board and there was nothing else wrong with the unit, all you did was replace that board, then what caused the board to fail? More than likely, it was a high voltage surge that caused that problem. Because if there's no other failure inside that unit, something caused it to fail.
Right. Something happened.
Failed because, the board just gave up the ghost. Not saying that it can't happen, but more than likely something external to it caused it. So at that point, I'd highly be recommending to the customer, said, look, I replaced this board on this unit. I found nothing else wrong with it. The machine's back up and running 100%. I think it'd be a good idea for you to add surge protection and voltage protection on this unit. So, what else? We got other questions?
Rocky says, will the unit run okay on 252 volts?
It will. We're getting at that top end though.
That's at the very top end.
About 253 is the absolute top end, and yeah, I'm not going to say it won't run, because it will, but
you gotta be cautious.
Well, they do make buck boost transformers too, where you can dial that voltage down.
Yes, they do.
So it may be a good idea. And where I see a lot of that is either where that unit's way out in the stick somewhere and they're at the end of the transmission poles, or new developments where not all the housing is being done yet. So that voltage is extremely high because they don't have much load on that entire grid yet. As the houses start building up, then you get more load on the grid, the voltage drops down. But trying to get the power company out there to come out and dial that voltage down, I've never had success with it. So at that point, you're just going to have to, use a buck boost transformer and bring it down.
Right.
But 252 that's on the borderline. So at worst case, put a voltage monitor on it that will actually shut it off if the voltage gets too high, so you don't have damage. And then if we keep kicking out on that, then maybe do the buck boost transformer to get it dialed down. So that's, but will it run?
It will.
It will, but I guess the other thought process when my head was going for just a minute there is, okay, it was 252 volts when you measured it. When did you measure it? 1 o'clock in the afternoon? I wonder what that voltage is at midnight.
Yeah. Yeah.
Because what I'm getting at here is, as the demand goes down on that grid, that voltage is going to go up. So if you're measuring 252 and you're out there in the afternoon when you got a decent load on the grid, it's going to be higher at night. So that's one of those units that I absolutely would be getting, at least at the bare minimum, voltage monitor on it that's capable of shutting that thing down if it gets too high.
Right. All right. Well, that looks like all the questions for now, Greg.
Right. Well, I guess we got some more video to play, and now we'll actually get into the actual board replacement. And
keep the questions coming.
Yep, do keep the questions coming.
Thank you.
All right, with that, let's roll some video.
When you change this board, there's rules you got to follow to make sure you're doing this properly. So first of all, I tell them, before you do anything, take a picture of the board and how the screws are installed on the board, because there's no such thing as a missing screw. Because, and you'll see once I get this out of here, it's all about how this board, remember I told you guys before, these things generate a ton of heat. The heat is dissipated through the heat sink. So not only is it a matter of the thermal paste, but the thermal paste, along with the way this board is screwed down and essentially torqued to that heat sink, all of that plays a role in whether or not the board's going to function when we get done with it. So, take all the screws out. Again, I'm not using the screw gun. So I'm pulling all these screws out, and as you seen when I was pulling these out of here, all of these screws, let me get my fat hand out of the way. All of these screws are recessed. Now these aren't because I already loosened them up. You got to, when they go back in, they have to be recessed like that. That's part of what I was telling you when I talked to the technicians on the phone. It's like, look, you have to make sure all of those screws go back in, and the ones that are recessed again, because that's what's going to guarantee you've got that board pinched down to that heat sink properly. So while I'm getting this out,
That one in the center right there.
no, I didn't get them all out.
So if you've ever got a control board without the heat paste, in the past they didn't ship them, and I think Greg, you mentioned that if they do ship it air freight, they ship a part air freight, they can't just put the paste in there.
That's absolutely correct.
So-
if the board comes air freight, they can't legally ship it with thermal paste.
So there may or may not be heat paste in there depending, but for the most part, the stock that we have now includes a little Ziploc bag of heat paste. Also, what I noticed was it's in a bubble wrap, pink bubble wrap. So the board is surrounded with that pink bubble wrap as well. So there's a good chance that they didn't see it, kind of like they missed the remote and throw it away. So if you don't see it, it could be in the bubble wrap.
Blue is in, and brown is ACL. So those are the two wires that Daniel was talking about. You got to make sure you get back in the same place. And then also you have your ground wire. So what I'm going to do, just to be on the safe side, is I'm going to do, like we mentioned before, and just take a quick picture of it. That way we know when we put it back. And what I was doing was also checking my picture to make sure it was clear and I could see it. But down here too, and it's really hard to see, but right at the top of that Molex plug is that little bitty tab. There's the release. And once you grab that release, the wires will pull right off. There we go. There's one, two. And if you get really good at it, which I'm not, you can learn where those tabs are, and you don't even got to pull the insulation back. You can squeeze right through the insulation. And then that's white plug. I actually have the picture that's in the picture as well. And these are your EVs and this plug here. So you can actually do this after the board is completely out. Now we can just unplug these and move them right over while we got the board out. And we still got the keeper in that one. How do we pull that off?
It'll come out
Oh,
of there.
because it comes out
Yeah.
without having to. Look at that. Every once in a while you get lucky. All right. So the thermal paste. So here's the reason why you want to clean off all this old thermal paste. Because if this board was actually failed, which it's not, you could have the board can burn to a point where you'll get solder pots and they'll lay in that paste. Then, if we don't clean that old paste off, and even if we apply new paste and we put that down on that heat sink, what will happen is you're going to have that piece of solder in there. The minute you power it up, you just created a direct short. You're going to wipe that board out immediately. So very important that we clean off the old thermal paste. And I also will tell guys on the phone, so multiple things I would tell them. Have a magnetic tray, because there's no such thing as a lost screw. Also, make sure you've got a glove, because you don't want that white nasty stuff all over you. So if you got some glove, you can clean all that old paste off, reapply the new paste, then get rid of your gloves, and hopefully
You
you're
want to
not...
make sure that you're also not smearing the paste into the threads, because that's going to cause a problem as you tighten the screws back down. So you want to kind of go away from it if you can. We've even had things as simple as just some debris, some dirt, some trash in between, and all it was a matter of taking the board off, cleaning it up, redoing the heat paste, putting it back on, and the H5 went away. So, you know, that's where that question comes in: have you replaced the board? And I kind of have an idea for what pictures I'm going to be asking for and kind of what I'm going to be doing. So
he took it off with a paper towel first. Now he's just using a cleaning wipe to it just to make sure we got all that old paste off of there. Now that brown little piece of construction paper looking thing, that doesn't get replaced. Now some of the board replacements I've seen will actually come with a new piece of that paper, which if you got it, you can change it. The other thing I will tell guys is to do is so how do you determine which components get the paste? And the easiest way to do that is put your boards side by side, just like we have here, and you're going to reapply thermal paste to the same exact components. So you do it on the board, not on the heat sink. And then again, like Daniel said, he kind of drags around the holes because you really don't want it in the mounting holes. And you don't need a ton of that paste on there. You just need enough that it gets good contact to the heat sink. And as you can see, the one with that construction looking paper here and here, those two components don't get any thermal paste.
now we want to plug these up first.
Yep.
Prior to putting the board on there.
So I'm going to use this plug first, just so I get it on there right. Then I'm actually going to pull up my picture. I believe it was blue that was on end. I'm just going to practice what I preach.
Green goes over next to that one.
So blue was on end, and I'm going to pull the insulator down over it. Green is in the center.
Yep.
The green,
and
yellow.
then brown next to it.
And then brown is over here. And it's kind of hard to tell, but if I'm going to tilt this up just a minute so you guys can see this, you'll see that fuse is right there. That's the fuse for the filter board, and it is built into this particular inverter. You can see that fuse is part of the board. So that shows that the filter board is part of the inverter driver. It's not a separate board on the new EO units. All right, so now I'm going to see if I can't get this all flipped back around the way it goes. All right, cool. So I'm going to pull this back over here. So the other thing that I've gotten tons of pictures from guys in the field, and this is what part of what stems what I was saying about trying to change these boards vertically, is I've gotten pictures of these screws broke off, missing, And it's like, wait a minute. Why? So, because they're trying to do it vertically up in there, they can't really physically get to it. There is no reason why we should ever break one of these screws, because if you're just gently doing this, them screws should be able to tap right in there very gently. And we shouldn't be tightening any of them all the way down until they're all started. And then we want to kind of do it uniformly so we get that board pinched to that heat sink properly. So the only way I can think of that they'd possibly be breaking these off is, one, they ain't getting to the board properly. Two, they're using a impact screwdriver on here, which they shouldn't be using. Or they're flat, just over torquing it. So, as you can see, there was little to no effort to me to get all these screws started. And you'll also notice that I'm not putting any of the outer board screws in yet, because I don't care about those outer screws. What I care about is these screws right here, which is what's going to pinch this board to that heat sink. And they're pretty long-winded screws, as you can tell. So I'm just kind of taking it easy on them. I'm not putting in any effort at all as far as pushing down on the screws. That one just started to grab, and then I stopped where I felt it tightening up. Same with that one. Same with that one. Then what I'm going to do, now that they all start to grab, I'm going to go back to the center of the board, get that one a little bit tightened. Then I'm going to go to this one. Then I'm going to go to this one. Then I'm going to go to this one. As you can see, I'm kind of working my way from the inside of the board toward the outside of the board. Now I'm going to do it again.
Kind of like torquing lug nuts.
Yep, I'm going to give it a little bit
Header
more.
bolts.
Then I'm going to go to the next screw next to that a little more. I'm going to go to the next screw here, working from the inner to the outer. And so there's really no torque specification, but you can pretty much tell the way I was turning there.
Snug.
I wasn't Superman in it.
No, they don't need to be that tight. They just need to be snug.
Then once all those screws are tight, then I'll come back and put these 4 outer screws in. Because ultimately what I care about is those screws. So like I said, the only way they can be possibly breaking those screws off is because they were trying to do that board in that unit. Yep. And they were using a screw gun. Mm-hmm. They weren't getting them started true.
And this board here, you know, pretty easily done if it stays in the unit. But you saw how easily we removed that control box assembly. There's no reason, if it's that easy to remove the control box, you're going to have to unplug all the wires from the board to replace it anyway. So, you know, just do yourself a favor and take the whole box out.
Well, and here's the other issue. As you've seen, when we took that ground wire out over there, I dropped it. Or Daniel dropped it. I don't remember which one it was. You drop one of these down at the bottom of that unit, you better find it.
And, you know, it's okay if you can't find it. Hardware store sells them. They're M3 by 13 or something like that. I believe we have it on one of the slides.
But all they got to do is take the screw with them.
Yeah.
Take one of the other screws
Take
with
one
them,
of the
go to the
other
hardware
screws.
store.
Go to the hardware store and
match up the
get
thread
it.
count, the length, and you should be able to get a screw. But as you can see from when I just changed that board, it's not a hard process, but it is a diligent process that we have to make sure we're following and we're doing that thermal paste properly. Because if you're not, you're asking for trouble.
It's an
So
M3
Daniel just-
0.5, 15 millimeters long.
There you go. So whether you're doing this board or you're doing this board, that procedure don't change at all. You can see I still got them same screws that are tightening this board, and then what I'm going to do is roll it over and show you that that board is tightening it down into that heat sink. The heat sink, if you look closely where we took the board out of the unit, that is in the airflow. You've got airflow from the fan running across that. That's part of what's keeping the fins cool, to be able to grab the heat out of the board and dissipate the heat off the board so that we don't...
It's all about conduction.
Yep.
So I want to move this board. This is out of a 115 volt unit, and we didn't have one down here, so I just wanted to bring and show this and talk about where we're testing the test points on this. So on the 115 volt units, we don't have a spot to check the DC bus, but we have where the wires connect, right, Greg?
Yep. So if you look, and the way these capacitors are wired, this blue and this brown, it's going to be giving you the capacitance off of both capacitors. They're giving you the boost off of both capacitors. So I can go up here on the board, because this is hard to see down in that unit. You ain't going to see this very well.
Right.
But I can actually measure that DC bus right here off of the brown and orange wires, and it ought to be 280, 300 plus. Remember, you got a 115 volt unit. It may not be quite as higher as a DC bus. So the thing is, you got to remember is the capacitors, as we talked about in the design and operation, the capacitors that are boosting that voltage and giving us that high DC bus are actually part of the capacitor box assembly. The capacitor box assembly is actually a separate part. You think, well, I could just test those with a capacitor tester. Well, no, you can't, because I haven't found a capacitor tester that goes high enough. These things are, I think they're
2,500, 2,200, something like that.
Microfarads or something like that. My meter don't go that high. I actually asked several other friends of mine and stuff if their meters would actually go that high, and they don't. None of them will go that high.
So ACN5 and ACL4 is what you're looking for. So it actually goes right here. That's where the blue wire goes. Brown, ACL4, which is brown. It's ACN5, which is blue.
Thank you. But let me get this shot on the side of this capacitor. This is how I knew. The blue wire and the brown wire, the capacitors are tied together here. So this is giving you the boost off of both capacitors. Okay. And I just was saying it wrong when the wires come up. So it's brown and blue, just like the PowerPoint shows, which is going to be ACN5 and ACL4. Now, you can see that on the wiring diagram as well. You will see the exact same wires. So the orange wire is essentially in the middle. You're not doing it there. You're doing it on the outer two wires, which is blue and brown. You can clearly see that in the wiring diagram. So if you have the guy on the phone, you pull up the schematic, you can look at the wiring diagram and say, okay, test the voltage here and here.
So another thing about these capacitors, if one of these is failed, you could get E6. So this is a good portion of the E6 issue. A good way to know if one of your capacitors is failed. You see that white plug right there? And then the other one has a white plug right there. Those will either be blown out or a hole in it if that capacitor is bad. That
makes sense to me, and I'm glad you showed that, because I've never looked at one like that to know that.
So, you know, if you don't have to worry about testing them. If one's bad, you'll see it. So,
but that is, like I said, that actually is a separate part. So if you ordered a new inverter driver and the capacitor's bad, it didn't stop you anything.
Correct.
Because the board may be perfectly fine.
You just have a bad capacitor.
We have bad capacitors. Yep. So.
All right.
All right.
All right. Welcome back, everybody. I hope you enjoyed that whole demonstration of changing those boards. It was kind of a slow video process, but we wanted to make sure we didn't forget anything, you know, in the whole process of changing those boards. As I've said, I've seen some YouTube videos of guys changing boards on different manufacturers of mini splits, and most of what I've seen is they pull the board out, they slap another one in there to hook it all back up. They don't do anything with the thermal paste. I've seen plenty where they don't get all the screws back in, and I've even seen where they drop the screw. And you know, whether it fails right that second or not, it's going to fail again if they're not getting all them screws back in there so that board can dissipate that heat. Because boy, I tell you what, them things will definitely generate some heat. So, and the only way you can get around that is, and you'll see in some of our newer products, I have to, you know, throw this one out there. So the new MultiPro Ultra, that unit there, it actually has a liquid cooled inverter. So it's got a aluminum channel where the liquid line goes up and it kind of goes in a aluminum channel on the front of the board, goes back down. And so if you have to change that board, you would just take that outer cover panel off, pull the liquid line back, unplug everything off the board, replace the board, push the liquid line back in, put the cover channel back on. So there is thermal paste on it, but the thermal paste is between that aluminum channel and the board. So when you order a new board, that aluminum channel is already on there. So you don't have to do anything with the thermal paste. But any air-cooled heat sink on an inverter board, then, and you're changing that board without changing the whole electric box assembly, you have to take that board out and you need to be diligent about doing that thermal paste. So we felt like this video was very important so that, because we have, I can't even tell you how many times we get a phone call where they've replaced the board and they say, okay, I replaced the board and now it still doesn't work. When I can't tell you how many times we've been able to prove to the point that they changed it wrong. They didn't do it right. So, and I like to stress here in what Daniel and I both do here. If you guys make a mistake replacing a board, we're not here to beat you up about it. We're not here to tell you fried the board. We're not giving you another one. That's not what this is about. This is about an educational thing so that you guys save time and money going out there, having the right tools, knowing how to do the procedure properly the first time so that you can fix that unit and go on to your next call.
Not having to make that second
back and do it again.
or third job site visit.
Right. So nobody wants to go back and do the same procedure twice.
Right.
So again, I like to stress this in our live broadcast, along with the Tech 90s. I don't know it all. Daniel certainly doesn't know it all. We learn every day just like yous do. All we're trying to do in everything we do here is passing on the knowledge that we know is the correct knowledge to you guys. And by all means, if you ever see us, you know, demonstrate something wrong or you got a better way, give us a shout out.
We'd love to know.
All ears. So anyway, with that, we're not getting a lot of questions coming in, so I really encourage you guys, you know, if you got questions, let's get the questions coming in.
Now's the time. So
We're happy to answer.
We did have one from Rocky, kind of a comment. Has their tape on some of the GBT that I'm guessing he's talking about, like the thin piece of white tape or the brown looking pad looking things that's on there. You know, we don't know for sure why that's there, but we do like to put things back the way they were found, just like the screws, making sure that the screws are all back in there and making sure that those pieces are back in there as well. So if you have a piece, a filament of some type that's in between the IGBT and the heat sink, go ahead and put that back after you clean it real good and put the heat paste on there and put that back in place.
So I don't know if I don't remember in the video if we discussed the fact, okay, what if you do get a board shipped to you, you get out to the job, and it was one of those boards that was air freighted and the thermal paste doesn't come with it.
Yeah, it doesn't have the heat
So
paste.
what do you do at that point? Well, if you go to like a Lowe's or a Home Depot, a lot of those stores do sell that thermal paste. Just make sure it's thermal conductive paste, not heat sink. Heat sink is to block heat.
Right. And the other electrical supply houses also usually will always have the thermal paste.
So if you're low, and I say that because I mean, I'm in a kind of a smaller town myself, and if I went down to Lowe's here, they probably wouldn't have it. It
Right.
depends on where you're at. how big of a store, how kind of electronics they're actually carrying. So, but there is other ways to, find the thermal paste if you need it. So, but the other thing to it is it doesn't have a real long life or shelf span in a bottle. So, if it's been sitting around, and that's what I tell guys, when you get to the parts house and you're picking up the board, unpackage the board, look in there.
Make sure.
Daniel, I think, pointed it out in this video. It comes wrapped up in bubble wrap. Undo the bubble wrap. Make sure you got that little plastic baggie of thermal paste. And that way, when you go to the job, you got what you need and you're not showing up without thermal paste. So,
right.
Because we don't want to take a chance of you putting that new board down on the old paste. Because I'm telling you, if there's a solder pot in there, you're going to know as soon as you apply power.
Yep.
So, but that and the screws, I can't stress that enough. If that board's not pinched to the heat sink properly, board's just going to get hot and fry. So, and I don't care if you're working on a GREE unit or any other mini split, anyone that's using a air-cooled heat sink is going to have thermal paste between that board and the heat sink.
Yeah.
So,
and even the one that you were talking about, the liquid cooled heat sink, there's thermal paste there.
Yeah, like I said, between that aluminum channel and that board, there is thermal paste there. Now, again, the replacement board's going to come with the aluminum channel already on there. So the factory did the thermal paste for you.
Right.
But, I don't know for sure if GREE, in some of the mini split line will start adopting some of the liquid cooled inverters. I don't know, but
now if I remember correctly, Greg, the actual copper tube that's set into that aluminum channel had heat paste on it as well. Because remember, we got it all over.
I think
we took that
did.
apart. It did. So in between,
I think we took it off of there and like, boy, I sure wish I'd had some plastic gloves on or some vinyl gloves with that.
Yeah, it got everywhere.
Because we had some units down in Atlanta that were damaged in our warehouse that we were scrapping. So that's what Daniel's talking about. So
before we wrap it up, and let's show everyone the image of the screw and the size of it and everything. We've got it pulled up.
Yeah, I think that's some good information there. So we did do the research to find out, what exact screws.
So if you do need to go to the hardware store and grab some of these.
So if you're watching now, we'll leave it up there for a minute where you can screenshot it, or that way you have that information if you ever do need to get some of those screws. But that's another reason why Daniel and I were saying, even though you could change that board right on top of that unit, you still got to get underneath that board to unplug everything anyway.
Yeah.
Why not just take the extra step and go ahead and move the whole electric box assembly? And I don't care if you do it in the back of your van and you got yourself a nice clean spot laid out, or you carry a little portable table that you can fold out and have yourself a nice clean working station, and have one of those magnetic trays so that when you do that board replacement, you don't have to worry about losing the screws.
Right.
You get it all back together. And now, if you're missing a screw that you needed to put the whole electric box assembly back in or put a panel back in, well, that's a lot easier screw to replace than the screws that hold these things, the boards down to the heat sink. So that's the only reason why we're saying, maybe you're better off just go ahead and pull the whole thing out and get yourself to a clean workstation. Yeah. But on the units where that board is mounted in there vertically, I can't stress enough, guys. Don't even try it. Pull that whole electric box assembly out, set you up a clean workstation, change that board, then put the whole electric box assembly back in, because you don't have enough room between the end of that unit and that board to get in there, get them screws out, get them back in straight, and not drop them down in that unit. And now you're going fishing, and hopefully there's not a snake down in there.
I was just fixing to say, remember that call that you had.
It was pretty funny. The guy says, "Oh my God, there's a snake in there," and he freaks out and he goes, "I go, well, was it venomous?" He goes, "I don't know. I didn't stick around long enough to find out."
And I wouldn't have
I
either.
wouldn't have either. So anyway, so sometimes there's something to be said that, you know, sometimes you make things a little worse to make things a little easier to make things better in the end. So I remember when I was in the field, there was a particular furnace I worked on. Getting to that flame sensor and igniter was an absolute nightmare.
Yeah.
And I learned early on the easiest way to fix that furnace was to pull the whole burner assembly. It took less time to pull the whole burner assembly, change the igniter, and the factory moved the flame sensor so you can move it to a more accessible area. Flame sensor to the more accessible area, put the whole burner assembly back in, was 10 times faster than trying to get a little 90-degree bent screwdriver down in there to get a little Phillips screw out. It just, you know, it was easier to undo the gas line and unhook some wires and pull the whole burner assembly.
Get it done. And
whether it's a gas furnace, it's a mini split, sometimes it just pays to take things a little further than you think you need to make things a little easier. That's all I'm trying to tell you guys.
Yep.
So.
Well, it doesn't look like we have any more questions, Greg. So appreciate everybody's involvement. And if you do have any more questions, feel free to go ahead and submit them. We'll try to reach out later. And
yes, I just want to, you know, thank everybody for participating. Sorry, I can't speak today. In today's broadcast, if you had to step away for a bit, or if you would like to go back and revisit any of this training today, we'll have it posted on our YouTube channel, GREE Comfort. You'll also be able to find it on our website. As a reminder, our next training, Talking Comfort Live, as always, will air on the first Wednesday of the month.
That's next week.
That's next week. And be sure and continue to refer to our training calendar page on greecomfort.com as we'll update upcoming trainings. They will be, okay, so we don't really, I'm gonna slow down for just a second here. We don't really do trainings throughout the summer because we know you guys are too busy, okay? So we kind of cut off June, July, August as far as technical trainings. So by August 1st on our website, we will have a whole updated calendar for the fall of 2024 and the spring of 2025, which will take us from September through May of next year. So we will be getting that. We haven't set the whole calendar yet, but we will have it up for you guys no later than August 1st.
And looking forward to some exciting new ideas that Greg and I have come up with for the fall.
Yeah, we think we do have some neat things coming up. I think we got some good ideas, and you know, we're going to try to change it up. We don't want to redo everything we did this year and duplicate it next year. I'm sure there'll be some repeats of stuff because I feel like it's important to, you know, cover important things more than once. But for the most part, we're going to try to change it up and keep it exciting for you guys, keep it knowledgeable for you guys, and, you know, hopefully you guys keep tuning in, and we appreciate everybody joining us.
All right. Well, thank you, everyone. And as always, don't forget at GREE,
by your side.